Now, weather message for NXDN also has another way of looking at your messages. And maybe those messages are from a day or two ago. Maybe they're from earlier today. If we take a look at our menu up on top, you'll notice that the third menu item here is something called logs. Every message that is composed is logged. Time stamped, station that sent it, station that received it, and the message. And that happens whether you're composing the message or whether you're receiving the message. Also, in our pull-down menu here, if I can get the mouse cursor to stay put, you'll notice that it also shows you stations. Yes, there is a station log. So the station log will actually keep track of when stations were heard. And even though you may not see a new station pop up on the screen, we had NB9X-11 up there, I believe, at one point, and we're just going to press that again, and it should pop up again. Now, I see why it's not doing that. It's because I had selected it. Let's see if we can. Not sure what's going on there, but we will look into that. Something misfired there, but we'll check that out. Anyhow, this does keep a running track of all the stations heard on frequency, and it also keeps a running time. So as the time updates, that will also show in the list.
I think if you type in NB9X-1 instead of welcome, that will fix it.
Probably not.
No?
No. In any event, let's go take a look at some messages that had been generated previously. So in the lower left-hand corner of our box here, we have several days of logs. If we wanted to take a look at today's messages, there they are. And we can scroll up and down, take a look at those messages, which may not, if we have stopped our computer and then restarted it, well, any messages that may have been generated or received 2 or 3 hours ago aren't necessarily going to just pop right up, because when you restart the program, it'll start with a clean slate. But if you wanted to take a look at something that was sent at 10 o'clock this morning or what have you, you go to the log, and all of this is available immediately online. Let's say you wanted to go take a look at messages from yesterday. Well, we just come down here to our box. Yesterday was the 23rd. There are messages that were generated on the 23rd. And so on, and so on, and so on. So you do have a means of logging all of the messages in the program, and you have a means to go back as far as you want to go take a look at the messages that had been generated. We'll close our window here. If I can get my mouse, there we go, to go over the close button. Again, we can also do that with our logs, with our stations rather. And so we're going to go select a date. Let's take a look at today. And there are entries in our station log for when stuff was generated and when we heard stations. We also have something here by way of a filter in the box that right now is blank because we wanted to show everything. If we just wanted to show messages from NB9X-7, we would just select NB9X-7 there, and it would display only those entries. One of the things with this program is that there are many different radios that can be used with weather message for NXDN. And in some cases, we may just take a radio, program it as a dedicated radio to this particular purpose. It only has whatever stations or whatever memory channels we want to have in it. Makes choosing those memory channels very simple. In other cases, we may take a radio that has programmed literally 100 different memory channels, and we want to be able to pick and choose. And we'll explain why we want to pick and choose here in a moment. Well, NXDN radios all support a traffic load of at least 128 memory channels. And most NXDN radios also can break those memory channels up into different zones. So we have to have a way of being able to take a channel from zone 1, and then maybe a channel from zone 5, and a channel from zone 6, and a channel from zone 3, so that we can populate our buttons that are right there along the lightning graphic. And those are the 4 channels right now in a particular radio that we may want to switch back and forth to. In the case of the computer that we have set up here that's up on your display, Direct 1 happens to be a simplex frequency that we're working with here in the EOC because we have a Faraday cage in here. It's virtually impossible to get anything into this particular room that we're in from the outside. So I guess to Mr. Giddy's presentation next door about securing radios in the age of Putin, Bill will open up the EOC. Just bring all your radios in here because there's not going to be an EMP that can get in here in all likelihood. And for a real demonstration of that, we will not ask Mr. Putin to set off a nuclear weapon. But in the real world, where we then could connect to an outside antenna or where we're not in an EMP-proof facility, we may want to go back and forth. So at this time, we're using a simplex frequency with talk group 1, but my radio may also be programmed with a channel called Seminole, which is another repeater in the West Central Florida NXDN network. And I may want to use that to communicate with somebody else. And in this case, the Seminole and the Boyette button, which is the one right below it, are both set up to communicate on talk group 1299. Okay, Paul, answer this one. Why would you want to have 2 repeaters that can both communicate on talk group 1299? Always good to have something in your back pocket. The Seminole repeater is very easy for me to hit. I mean, it's literally right at my house. The Boyette repeater is 33 miles away, but I can get into the Boyette repeater with an outstanding signal. In fact, even with a portable radio. So if for some reason the Seminole repeater would happen to be unavailable, I can immediately channel change, not by having to go to the radio and spin the dial, but by simply pressing a button. I can change to Boyette, send that message on talk group 1299, and it gets through. And here's one of the other benefits of that. If I'm using the Seminole repeater and I need to communicate with WX4TBW at the National Weather Service office, which is right down the road from where we are right now, I can't do that from Seminole unless it goes through our complete NX Core network. So I can send a message on talk group 1299 because that will pass the network. But if I wanted to send a message specifically to WX4TBW and only that station, I can't do that through Seminole. But there's the rub. I can do that through Boyette because the Boyette repeater will likely be the repeater that WX4TBW will be operating through. There is a method to the madness. So We put these 4 buttons in place so that the user will have some flexibility. If maybe all they want to use this for is talk group 1299 Skywarn traffic, they can put up to 4 different repeaters that they can hit, assuming they can hit 4 repeaters, all on talk group 1299. And if one goes down, they can immediately channel steer their radio without having to touch the radio by simply pressing the button. We have made this really, really easy. Now, in the case of our demo here, the 4th button up there on the list is labeled SEM 1200. So we have now just gone from talk group 1299 to talk group 1200. So maybe now I just want to send a general text message to everybody on 1200 or to somebody specific, but it goes through a talk group because they're on a different repeater. So that's the kind of flexibility that we have with our system. We can go from different talk groups, different repeaters, all with the press of a button. How do we do all of that magic? Well, in the background, we have a settings file. And I'm going to open one up here, the one for this particular radio. And for this particular computer, this is what your settings file looks like. You'll be asked to put in your call sign, your name, a Skywarn ID if you have one, and if you're using this for Skywarn, probably not a bad idea, and the NXDN ID. In this case, for this particular radio, because of some of the limitations of radioid.net, that happens to be an ID that was grandfathered before radioid.net ever got involved with doing this. So I have several radios with several different IDs. If all you have is the one ID, it's not a bad thing, but just remember too, and this is one of the things we didn't mention this morning, if you've got a portable radio and the ID is 12345, and you've got a mobile radio with the same ID, your wife will never hear you when you're using the portable because the 2 radios with the same ID can't talk with each other and they can't hear each other. It's kind of like 2 computers with the same IP address. They don't work well, but they'll still work talking with everybody else. All right, so you put that information in. Then over here to the right, we have something called serial port. And the program is written in such a manner so it will go out and scan your computer for all active serial ports. You might have just one. You might have 12 serial ports that have something that have activated them. Maybe it's a real device, maybe it's a virtual serial port. But the program is designed to collect all that information, and then you pick the serial port that will work with your radio. In the speed, all things serial have a baud rate. And in a lot of cases, you may use the default 9600. You may use 4800. That's still fast enough for NXDN. Or you can do what I chose to do and select something a little bit faster at 19200. That is the speed with which your radio and computer and all of this will communicate at. Then finally, we have our button table. And because of the way the radio that's connected to this computer was pre-programmed, didn't have to add anything to it. I just took what was already there. Direct one happens to be on channel 14. Direct, or I should say Seminole, happens to be channel 24. That tells me that that Seminole channel is in another zone And so when you're adding all of this up, if you have a multi-zone radio that you're trying to use with this program, you have to cumulatively look at the number of memory channels that are allocated by zone. And if it's in something other than zone 1, then you need to start adding those numbers together. And that's how you got to, or how I got to, channels 24, channel 23, and then zone, or the final channel, Seminole 1200, happened to be in that first zone in memory channel slot number 8. I know this can be a little bit confusing. The online help that comes also with the program does go into a rather detailed explanation about this. And if you do have a radio that has multiple zones, multiple memory channels programmed, probably a good idea to get your programming software out to make sure that you've got your number count correct. One little thing that can trip you up in all of this is if you created a zone with 16 channels, but you only have programmed 14 of the 16. When you're counting up the number of memory channels to finally figure out what channel number that memory channel in zone 4 needs to be, you've got to include the other 2 channels that have nothing in them. Because as far as the radio is concerned, they're still allocated. So in this case, that's how we got to 24 and 23. And if we only had 15 channels in that first zone, but there were 16 allocated, zone 1's numeric factor would be 16. Okay. Now we can choose to make changes here. We could choose to leave it as is. If we leave it as is, we just simply hit the cancel button and it tells me, are you really sure you want to do that? And we say yes, and everything remains the same. Had we made some changes, first of all, we would have gotten the dialogue that would have said, are you sure you want to make these changes? The answer is yes. And then in order to implement those changes, we want to restart the program because it needs to be able to read that file again. All right. As I'm going back and forth here between channels, there is software or a routine in the software that channel steers the radio. So it can hop around in a very unlinear manner between 14 and 24 and 8 at random. You press the button, it knows which channel to pick based on what you put into the configuration. And that makes using this program very, very easy. You're not fumbling around with the channel change knob or a zone change button to try and find the channel that you actually want to be on. It eliminates all of that. So I've got to ask the magic question. You like it? Is there anything in here that you would like to see that isn't there?
You know, one thing I always wonder about is how can somebody find out what all fault groups exist on a system like this? You know, and what they're used for.
Okay, so the
1299 is used for this. Well, how would I know that if I did, you know, wasn't in?
Actually, I've got a really good answer for you. It's called https://ni4ce.org.
It's all there.
It's all on there. If you go to the upper left-hand corner of our webpage, you'll see a little button with several horizontal lines. You click on that and pull down, it give you a pull down menu, click on NXDN, and all of this information is out there.
All right.
We did cover some of that this morning. And Daryl, the PowerPoint that we did this, or that we used this morning, is that going to be available online as well? It will be. Okay, so the PowerPoint that we did this morning that also has a slide with all of that information will be online come Monday, and you can look it up, but we also have it on ni4ce.org. Any other questions? Yes, sir.
Are the top numbers like 1,200 and 1,299, are they uniform at all with any other groups? So if I wanted to say a group in North Carolina, look those up, would they be 1,200 is the general talk group?
No. They're not. They're unique to West Central Florida. And let me give you a little history about how these numbers evolved. The U.S. government has a set of identifying numbers called FIPS codes. And I'm not exactly sure what FIPS stands for. It's another one of those government acronyms. But the FIPS code for the state of Florida is 12. Georgia's 13. Wisconsin is, I think, 55. Texas is 40 something. Well, in the process of trying to set a baseline for all of this, we said, okay, the FIPS code for Florida is 12. So let's make our home talk group for the state of Florida 1,200. And let's say North Carolina would be maybe 34. I don't know that that is the case, but let's say North Carolina is 34. North Carolina's home talk or statewide talk group would be 3,400. Now, we've evolved into some of these others by virtue of some of it is FIPS code, some of it is pick an arbitrary number, throw it up and see if it sticks. In the case of 1299, which is the Skywarn talk group assigned to the National Weather Service office, Ruskin, we have a different talk group for National Weather Melbourne, National Weather Jacksonville, National Weather up in Tallahassee, because eventually NXDN is going to catch on and it will be in all of these places. I may not live to see it, but hopefully it will. So bottom line is, if I want to talk to Tallahassee, it's got to have a different ID number than Ruskin does. In this case, we arbitrarily said Ruskin is 1299. You'll remember from this morning's presentation, we talked about a Charlotte County talk group of 1215. Well, how we arrived at that is that the FIPS code for Charlotte County is 12015. We just eliminated that zero in the middle. Now in Lee County, because there might be a 1271 for something else, we actually did use the full FIPS code for what we're calling Lee Link. Now that we have a repeater in Sanibel Island and one in Charlotte County, just west of US 41 that covers a good part of Lee County, and another one at Babcock Ranch Village, which also covers the eastern half of Lee County. If you use talk group 12071, which is Lee County's FIPS code, you light up all three of those repeaters at the same time. And at the same time, even though two of those three repeaters are in Charlotte County, you're not bothering the Charlotte County folks because they've got 1215. And repeaters do support multiple talk groups. So all of this, again, is out on ni4ce.org. If you're in North Carolina, you'll have to consult with whoever is up there. But again, the FIPS code was the basis for where we started with all of this. The guys at radioid.net have kind of ignored that as they're putting out IDs, but you know, it is what it is, and we have to live with that, I guess. Yes, sir. Well, it's a good idea if you're buying an NXDN radio for the first time. Go to radioid.net, have them give you an NXDN ID. And then that way, at least at the moment, you'll have some modicum of assurance that if you take that radio any place in the country, or for that matter, the world, it will work.
Like two radios, separate ID, you get like two IDs from radio ID.
Well, the guys at radioid.net take a very, I think, narrow vision of all of this. They believe it's one ID per call sign. And I'm sorry, folks, if you've got more than one radio, you really need to have more than one ID if you expect to use this radio to talk to that radio. Yeah, they haven't figured that out. Part of the genesis for that also, in all honesty, is that NXDN is based on a 16-bit numerical platform, which means the total number of available IDs is 65,535. And, you know, it is what it is. Having said that, we've already got folks working on how to try and expand that to some number that is much larger than 65,535, which is 16 squared, by the way. And we're working on trying to get that so that if you're in North Carolina, it works. If you're in Florida, it works. If you're in Alaska, it works. But it is one of the limitations. Frankly, in the world of digital radio, P25 has already gone through this. DMR has already gone through some of it as well. And I think when NXDN was first created in 2005, the folks, the engineers behind all of that probably had the same vision limitations that the folks who created IPv4 for our IP addresses had. It will never run out. And in a lot of cases, they're probably right, because you put in an NXDN system for a corporation or a government entity, you know, you're going to have 65,000 radios on that. Well, maybe not. So I hope I answered your question. It was a little bit roundabout, but whatever. Anyone else have a question here? Because we're kind of sort of running to the end of our time limit here, and I don't want Daryl coming up here and giving me the hook. And Daryl's got a hook. I mean, you know, and it's steel, so it's likely to hurt. Well, yes.
Can you make up your own ID? You're not planning on taking it out.
The answer is yes. And because the NI4CE, because our repeater network is not connected to the internet, I mean, we could use all 65,000 IDs. So if you need a second ID and you need to make something up, you know, I'm not gonna give you a noogie. One last thing I want to mention. We've got several different radios here in the mix today. The computer that you're actually viewing on the screen is using an ICOM F62D. Very good radio, very capable radio, and it interfaces with the computer a couple different ways. We're using the programming cable right now as a means of connecting to the USB port. The 62ID also has Bluetooth in it. So if we wanted to connect the radio to the computer wirelessly and use Bluetooth as the transport, we could do that. We're pretty cool. Now, to run the gamut, our other computer over here is connected to a first generation F4161DT. That is, this particular radio is not, you know, a 2005 manufactured radio, but it's from that vintage. So NXDN messaging, while it does not work with all radios, there are radios, if you've got a 4161 or a 4261, which were first generation radios, it'll work with this messaging app. the 62D, the F4400 that Daryl has, the F6400 mobile, all work with this program. And how you can connect to the 4400 and the 6400 is through the programming cable, through a USB cable, and both the 4400 and 6400 have Bluetooth, so you can also connect wirelessly to your computer. And I'm quite sure that whatever new third generation radio ICOM is working on right now will also connect likely with Bluetooth, maybe even with USB-C. So I don't know about Wi-Fi, but you know, we can dream on. So one last thing I do want to mention. If you have a Kenwood radio that does NXDN, as you know, you can do NXDN voice with it just fine. But unfortunately, Kenwood decided to go a different direction with their texting capability, and it's not compatible with ICOM. So if you send a message out with an ICOM radio as your transport, somebody receives it with a Kenwood radio will receive a signal, and it'll look at it and go, yeah, this is digital, but I don't know what they're talking about. It's a bunch of gibberish. And the same thing, vice versa. If they send a message out with a Kenwood radio, ICOM radios look at it and go, I know it's something, but I don't know what it is. It's like, you know, somebody speaking German and somebody else talking Spanish. It's a different language. We're working on seeing if we can get some connections there, but so far, unfortunately, we haven't been able to get Kenwood's attention. If somebody out there is watching this and you're from Kenwood, we need your protocol. So with that, thank you all very much. I'll be around here for a while. If any of you have questions, we'll take them offline. But thank you for joining us today here at TECHCON, and may the messaging be with you. Thank you. Thank you very much.
Microphone, please.
Ah, yes. There we go.
Yeah. My other one disappeared after the last Aries meeting. Had to be mailed back to me. So, oh, I left my descriptions over there. Pardon me for a moment. I'll get those up. Okay. Oh, there it is. All right. And somebody will have to come sign in on that computer. While we transition over here. There we go. And hopefully you got your stuff all on flash drive, because I didn't even have a chance to download or anything. All right, there it is. No, go ahead. We'd have to, well, let's figure that out. We had scheduled, and again, we could switch this if we need to, but this has a USB-C cable on it. And you sure you don't have your stuff on flash drive? I got a flash drive. I mean, you know, if you got some in my bag over there. How many were planning to do the GW Basic with Windows 10 presentation? We did have a couple of takers. All right. Why don't you go ahead and go to that room and do that, and when we can get that re-recorded or whatever. And because Gordon is due to come back for his 5th time around today. He's been very, very in demand today. He's going to be doing a program on creating a noise calibrated monitoring antenna. That's going to be quite interesting. So I'm going to let you come up and load your presentation, and In the back room will be converting GW basic programs to run on Windows 10, or I guess a Windows 11 for that matter. So so Mike, you folks can follow Mike to the second track, and Todd, you may have to adjust the camera for them so they can actually see it, being that they're going to have to be a small group. Well, I guess it doesn't matter. He'll get the slides and add them in after the fact anyway. So there we go. I guess that won't really matter. And wow, look at this, hands on. What's that now?
You have the talk on your computer.
Let me get that flash drive out. Hang on here a second. Good thing that I don't need to tamper with it right now. All right. We just got this machine back up. All right, now there's the mouse. And oops. Okay, the mouse is disconnected. No worries. All right, this should be quite interesting. There we are. And it's going to be calibrating noise measurement antenna. There we go. Making sure I got the right one. Oops. Oh, that's right. We lost our connection here. I got to plug that back in. And I know the C cable's over here on the right side. Hopefully our video will come back up here in just a moment. And let's pray that it does. All right. Hey, there we go. 9 out of 10 monitors ain't bad. So this time we're going to be doing in this track now, creating a calibrated noise monitoring antenna and using to measure a baseline at an EOC construction site. So flip on mic is yours, and that's for the recording, and the mic is for the
All right, you guys are trippers to put up with all this. Done more electromagnetic theory today than I've done in years. So here we go. Well, why the heck am we doing this? So our EOC was built to destroy ham radio communications 20 years ago with the most amazing noise generators you could imagine. Solid state backup, uninterruptible power supplies, generators, oh my gosh, computer systems, and all the computer storage for the whole county in that building. Horrendous noise on all of our antennas. So we had to solve that, and they've decided to build a new place. So we're desperate not to let them repeat the issue, because the new place does not have a set of woods behind it that we can go hide our antennas in. There's a park behind it, and we will get into trouble if we do that. Let me see if any of these works. Yeah, this one works. Okay. So this is the way that professionals talk about noise. And this comes from the Radio Society of Great Britain and from the ITU, International Telecommunications Union. And they talk about noise. These are frequencies. This is the 3.5 megahertz band. This is the 30 meter band. This is the 20 meter band. And they measure it in the E field, the actual electrical field, in dB microvolts per meter. It's not just a voltage, it's a voltage over space. And it's the strength of the E vector of the electromagnetic wave, which, as you remember, is a transverse wave that has magnetic and electrical potentials to it. So galactic noise from the universe and all of the lightning storms that happen all over the earth produce noise. And this is what, like, suburban noise looks like this, rural noise looks like this, and quiet rural supposedly looks like this. And that's what the ITU said. The Royal Society, Radio Society of Great Britain did some measurements. Their measurements don't completely agree, but it kind of falls in this range at their measuring sites. They spent years trying to measure the noise. So I can't present stuff to the builders of the new EOC in terms of S units. That's not going to be a professional term. And if I give them dBm off of a spectrum analyzer, it depends on what antenna was used. So I need to be able to use industry standard specifications of E field of noise coming off of equipment. So I need a calibrated antenna. Oh, that's no problem. They sell them. It's a 3-foot monopole with a high impedance input amplifier, and there's also a ground plane that goes with it. And if you'll just let me have the 3000, I can buy a used one so I can make my measurements. Takers? I didn't think so.
Yeah, you said it's a 3-foot. Is it 3 foot or is it 39 inches?
Oh, I'm sorry. It's 1 meter. 1 meter. And these are pretty nice antennas designed to work up to at least 30 megahertz, if I remember right. And it's calibrated. So one of the things that always perplexed me was, so if you put your antenna up, how much voltage are you going to get off the terminals? And nobody ever told me the answer to that in engineering school, but it's in Wikipedia. So there's this number called antenna factor. And because it's a factor, you multiply it. And so you multiply it times the electric field strength, or if you're using dBs, you just add them. And it tells you the voltage that you're going to get on the terminals of your antenna, which is, I think, really cool. And obviously it depends on the antenna, right? So for this $3,000 job, it's been measured, and they can tell you the calibration of the antenna factor for every frequency. Okay, so the CISPR standards in Europe and the FCC Part 15 standards in the United States all use a vertical monopole type antenna. In the FCC stuff, it's buried. I don't know how many different abstractions you have to go through to find where they really said to do it, but it's some NTSD standard eventually. But it's a vertical antenna. That doesn't do me much good because we don't use verticals. We need to reach Tallahassee, not California. If my goal was to reach California, well, a vertical would be great for DX, and I can work Japan and Asia while I'm at it, but I need to get to Tallahassee. And in order to get to Tallahassee, I got to do this maneuver. And in order to do that, I don't need low angle radiation from a vertical. I need high angle radiation from an INVIS antenna, which is a horizontal antenna that is at a modest height instead of a huge height. So we have done all of our measurements with horizontal antennas because it fits what we need, not what the standards are written for. So there's this Ohm's law problem. We get these measurements off the spectrum analyzer that are in dBm, decibels related to a milliwatt. And those are power. And we need to convert it to voltage. So then we can use the antenna factor to convert it back to E field in volts per meter. Oh my gosh, this takes some math, but it ends up that it's this equation. The dB microvolts per meter of your E field is equal to 107 dB plus whatever dBm your spectrum analyzer says, assuming it's calibrated, plus the antenna factor of your antenna, assuming that's calibrated. And I actually did derive this, but it's easier just to look it up because all the EMI guys and EMC guys, this is the equation will always show up on their website. And it involves the 50 ohms. I think that's what gives you the 7. And it involves dealing with voltages and microvolts and dBms, which is millis, and we're talking about micros. And so there's some switcheroos with the decimal points. Well, I don't want to pay $3 grand. So how am I going to calibrate some antenna that I can easily carry around and use for all my measurements? How am I going to, I got to become my own calibration standard. Well, it turns out if I had an antenna that I did know its antenna factor, I could use isotropic noise in the environment as my standard, and I could measure it with the known antenna, and I could measure it with my proposed measurement antenna. And I could do a little math between the two and theoretically get a calibration for this antenna. So that is what I tried to do. So it turns out, and you can get this off Wikipedia, that if you've got a full-size dipole, the antenna factor is known. And you can actually calculate what voltage will be developed by what E field by an 80-meter dipole, or a 40-meter dipole, or a 20-meter dipole, or any other antenna. And that antenna factor is equal to 9.72 divided by the wavelength times the gain. What gain do I use? Well, we're talking isotropic noise. Doesn't matter what the gain of your antenna is. Noise comes from all directions. So what you pick up from one side, you're not going to pick up from another side. So in effect, the gain of an antenna is always 1 if you're talking about an isotropic source, which is noise. So I ran these numbers, and on 80 meters, the antenna factor in linear terms is 0.113. I think that means that your voltage will be 1/10 of the E field. I'm not sure about that. And if you convert it to logarithms, remember there's a 20 log because it's voltages. It's about negative 19 dB, dB whatevers. And on 40 meters, it's negative 13. And on 30 meters, it's just about negative 10. So you can actually have a calibrated antenna that you can hang up in your backyard, and you can actually know what its antenna factor is. So that's pretty useful. Okay, I already ran through that horrible equation once before, so I'll skip going through it again. But this time I gave you the reference. I pulled it off of AH Systems Useful Formulas for RF-related conversions, but it's everywhere. It's always the same because it just comes from Ohm's law and 50 ohms. Again, noise is noise, so it doesn't matter whether I measure it with a big antenna or a small antenna. We're in the same E field close, because unfortunately I didn't do my experiment perfectly, but it was good enough for the start. So here's what I did. I had my antenna out in the backyard, and I knew its antenna factor. I made the simplifying assumption that even though it's a 100-foot non-resonant antenna, it's close to a full-size antenna for several different frequencies. That's not exactly true, but for a first cut effort, it was good enough for me. I made sure it was tuned on each band when I made the measurements by setting the SWR individually for each band, make sure it was tuned right with an antenna tuner. So I got all that right. And then this has a 10-foot RG8X cable, and that is part of the loss system because this is certainly not matched. It is not tuned. And so that introduces loss, but that gets built into the antenna factor for each band. And so it's inside the fudge factor. Goes into a 50 ohm spectrum analyzer, a SIGLIT in my case. But I can only get 10 feet away from the spectrum analyzer because that's all the length of this cable. And if I add more length to it, I'll change the measurement because the loss will get worse. So the mistake I made in retrospect, my antenna was outside and I shoved this thing 8 feet out onto the top of my porch on the shingles out the second floor window. And I think my measurement's pretty good for 80 meters. But other work that I've done since then suggests to me that my measurement for 40 meters and 30 meters are a little off. So I'm going to have to go redo those measurements by going into the backyard and holding this thing up near my other antenna. And I may cut an 80 meter and a 40 meter and a 20 meter antenna and literally hold them all at about the same place and redo these measurements because I've concluded it's not perfectly accurate. But here's what I got for my first cut at this was, I think that number's correct. I think that number's off a bit and that number's off even more. But typically a short antenna does this kind of a number. where you have to have more of a correction for the lower frequency, and the antenna becomes better and better as you get to a shorter wavelength, because it is short, and so it works better at shorter wavelengths, higher frequencies. So this is the calibration that I came up with. Oh, I already told you this. So I think my 40 meter, 30 meter efforts are not quite as reliable as I would like. Okay, so we're moving the EOC. And I want to have proof when these jokers put in stuff that makes my life miserable. So I needed a baseline of what was the noise before you guys brought in all your equipment and installed all this fancy. So we needed to make this, and I went out there to try to make this measurement of what the baseline noise was at my EOC. And anybody can do this. This is not hard. If you duplicate this antenna, which is real simple, it's 1 foot of shield this way and 1 foot of center conductor that way, and then 10 feet, RG8X, connect to your spectrum analyzer, done. $3,000. Did I have any takers? I did one just for fun, but I don't think they have anything to do with it. I don't think they have anything to do with it. So the first time we did this, I set up out here on the front lawn. There's a power line there, and that had me really nervous. And the second time, you'll see we had to redo the measurements because we made a boo-boo. Second time, we have our card table here. We're out in the back of the new EOC, and there's our antenna and spectrum analyzer, and a very patient friend helping me make these measurements. Here was the first boo-boo we made. So my spectrum analyzer is a nice $1,400 SIG length, but it does not have a 12-volt power input. I wished it did. It only has 110 volts AC. So I have to have 110 to run the thing. And so stupid me, I have this special inverter system with ferrites everywhere that we use during field day to run our computers to be legal. When we tell them we're running off solar panels, I actually run the computers off the solar panels also. So I have to run the chargers for the computers. But we had this noise. This is like 0 to 30, and this is FM. These are FM transmitters in my home city, and I don't know what that is. That's something, but these are FM. They're all at FM frequencies. And we thought this was real. We thought, okay, that's the baseline noise. But when I went back home and looked at data that I had done years earlier, I discovered that at my house, and I can't read that. Let me see where that is. That is up to negative 85 at the peak, but it should have been at negative 110, because that's where my house is. The noise in my house on this antenna is negative 110 dB. So I said, uh-oh, I think my power supply isn't as quiet as I thought. And I went outside and cranked up the diesel generator, which has no voltage regulator other than a mechanical governor. And it makes almost no noise. And sure enough, it was much quieter. And when I powered the same system with this antenna and my little inverter, it looked just like that. So I made my own noise. So we had to go back and make the measurements over again. The other thing that I've discovered is that utility power is almost always very quiet. And if you're worried about it, you can put a filter on the AC line that you're using for utility power. A ferrite with 11 turns through it is a pretty good shot. Or you can buy, the filters are like $11 each on Amazon. You can buy filters that have pretty good rejection. So we went back and did the whole thing over. We did it a couple of different ways. I took the whole diesel generator, it's on a trailer, and I took it with me, and we set it on the other side of the parking lot. We ran 150 feet of extension cord to get it as far away as we could. And I used a $123 MIF-23 filter on top of the diesel generator, which has like 50 to 100 dB of isolation. So I did everything I could to get the cleanest power I could possibly get. And I redid all the measurements, and sure enough, it was quiet as all get out. And on the other side of the building was vacant when we did this. We discovered that there was a power outlet on the outside that worked. So we made measurements with it as well, and they were the same. With the diesel generator, with the outside power, it was all the same. This is an example of what the MIF filter does. For a differential mode, it's up to -80 dB. For a common mode, it's almost 100 dB. This is 1 megahertz. This is 10 megahertz. You see a little bit of decline there down to about 80 dB. This is 1 megahertz. This is 10 megahertz. So it's in the 70 dB class. It's a very nice filter. It's intended for industrial applications to quiet down pulse code modulated machines that do all kinds of machinery kind of stuff. Okay, so we did 2 different locations. This is a satellite view of where our new EOC is going to be. This is a high voltage power line. This is supposed to say tree, but it doesn't. It says tray. Here's the ancient building. This building was used to monitor Soviet to Cuba radio transmissions in the 1950s, I believe, in Gainesville, Florida. They must have antennas. I don't know what they did, but they tore all that stuff out. So, but it was apparently a very fancy building back then. We did one measurement behind the building because we want to put antennas here and here. And we did one measurement here because we want to put a tilt-up telescoping tower with a beam on top and antennas on top too, verticals at that location. So we did both of these locations. And here was what we got. So the dBm measurement comes from the spectrum analyzer. And all of these were just slightly higher than the baseline noise of the spectrum analyzer. You always have to set the spectrum analyzer and measure what your noise floor is on the analyzer itself. And thankfully, I could get down there. You generally want to make these measurements at a 9 kilohertz bandwidth. Because remember, noise is white. The more bandwidth you use, the more power you'll pick up, right? So there's an agreed upon 9 kilohertz. The only problem is my cheap spectrum analyzer can't do 9. The closest it can do is 10. So there's a conversion you can use to fix that, but it's like a very small amount of fraction of the dB. It's not worth worrying about. If you believe my antenna factors, which I think a couple of them are off, then you can calculate the dB microvolts per meter. And at 3.5, which is the one that I believe, at location 1, I was 0.1 dB microvolts per meter. Compare this to an EMP, which is 25 kilovolts per meter. And this is microvolts per meter. Now you see why an EMP is a problem. At location 2, we were slightly more noisy, 2.1 dB microvolts per meter. These numbers, I'm not for 40 and 80, I don't think are, excuse me, for 40 and 30, I'm not convinced are accurate. I want to show you how this compares to what we did at the old facility. Now, I didn't have antenna factor back when I did that. What I had was just dBm, but it was this antenna, the same exact antenna. And this is stuffing that antenna through the trap door onto the roof of our EOC, where our big fancy antenna was hung above the roof. Now remember I showed you the measurements before, which was like negative 122 dBm. Well, this was negative 60 dBm. That is 60 more dB of noise where our antenna was on top of the roof. 60 dB is 1 million times more noise, which means if you could receive a 1 watt signal at our quiet location, you would need a 1 million watt signal to hear it at this location. So no wonder we were deaf. Now, this was data that we did. This is the noise floor back when I made that measurement. I didn't have it set up quite as well as I did this time. And these were measurements that were done in the parking lot and on the back corner of the building. And what we discovered was the noise that our building generated was near field noise. Normally far field noise goes down by the square of the distance, and that's not too fast, but near field noise goes down by the cube or the fourth power of the distance. So near field noise from a radiator is much easier to get away from. And what we found was if we went into the adjoining lot, which the county then bought, and put our antennas up in the trees about 75 yards away from the building, we got down to acceptable numbers. And so that's what we had to do. And this chart was the proof that our noise was a near field phenomenon that we could actually escape. But these noises, this is negative 80 dB, whereas the new EOC is like negative 120. It's 40 dB quieter. That's a phenomenal difference. That's 10,000 times quieter. So the reason we did all this, now here's what shows why I think those other two numbers are not good. I took those numbers and I plotted them on the same chart that you get from the Radio Society of Great Britain. That's our 3.5 megahertz quiet number at the new facility. That's our 7 megahertz quiet number. It's not too far off from a measurement that the RSGB made. There's our 30-meter number. Oh, nobody was that quiet. So I suspect my measurement is not correct there. Whereas I suspect my other measurement is correct because even pushed out onto the parapet over my back porch, it's not too far away from the antenna. And 80-meter energy is probably still about the same there. Okay, so I know this is noise is something that hams deal with a lot, but in an engineering perspective, it's not something that we deal with a lot. And the concepts of white noise, the concepts of dB microvolts per meter, all these fancy ways of measuring stuff is a little bit foreign to ham radio operators who are used to thinking in terms of S meters, which are unreliable. I made measurements on my S meter and it was 3 dB per S unit, not 6, like it's supposed to be. And I published that in one of our papers. Making accurate noise measurements is very tricky. It requires attention to inadvertent corruption due to power supply noise. And that's what happened to me the first time I tried it. I think our antenna factor calibration for 7 and 10 is suspect. The new EOC site, it doesn't have anything there yet, is very quiet. Well, that's what you'd expect, but we proved it. It's not, there's not noise coming from the neighborhood. That power line out front apparently is quiet. So we're in good shape until they start adding all their equipment. Now, we have written papers, white papers, telling them how we think they can equip their building and avoid causing problems. And I've got a paper I'm going to try to submit to QEX on some of that data that we've written. But we did this so we would have the goods on them if they cause us a problem. And we say, look, you know, this was a very quiet place until you added that air conditioner. So would you be willing to now retrofit it? Because it does not have the specifications that we suggested to you were necessary in real life, and maybe they will listen to us. Then, because I already have the dBm measurements, when I get the correct antenna factor, I can just go back and change the multiplier and redo that data without having to go remeasure anything. And I can take the data from our measurements that were done years ago at our EOC, and I can convert those all properly to dB microvolts per meter. I just need to redo. My first set of efforts was not quite 100%. So if you need to make a measurement either at your house or at a professional facility like at EOC, if you've got a full-size antenna, it's real easy to do. You can calculate the antenna factor yourself, don't need to do anything. If you want to be able to carry it around, then you want to build something like this, and you want to get me to finish the calibration of it so you don't have to pay the $3,000 to buy their thing. And if I can get this published in QEX, then we'll actually have a paper you can refer to, and then we can all measure noises. I'm aware of some EOCs where frankly, they just can't do HF because of too much noise from HVAC systems with switcher motors and things like that. And we would like to avoid that because HF is the backup system that may be all we've got if somebody destroys all of our satellites. Okay, so any questions, comments? Yes.
So, how do you write this into the specification for the suppliers for putting in power systems, HVAC, all the rest of that?
Great question. He's asking, how do we actually write specs? So I gave this talk about an hour or two ago in the other room. We did measurements and a anecdotal setup, my house, only one I had. And we actually measured what was the noise signature of one particular device. And then we measured what was the radiated noise that my antennas picked up. The noise signature of the device was conducted noise, which is how the FCC measures that kind of thing. And since this is all a linear system, there's no amplification of the noise once it comes out of the device. It's just radiated and picked up by my antenna. It's a linear system. If you cut the noise generation by 10 dB, the pickup will also cut by 10 dB. So we were able to measure the baseline noise at my house, and with this amount of noise added by this device under test, which was a generator, an inverter generator, we were able to show how much noise, my noise floor went up. And so then we could say, well, if you had met Class B standards, home standards, it would have been okay. If you had exceeded Class B standards at this frequency by 5 dB or whatever, it would have been okay. So we are able to take those measurements and tell the manufacturer, you not only have to say that you meet Class B standards, when we install it, it needs to meet Class B or exceed Class B by this amount. And if it does that, we should be okay. Class A, you're going to have to exceed by a good bit because Class A is industrial standards and they're a lot looser. But we did that measurement. We've got that data. That's part of what I'm going to try to publish. And it's just one instance at my house, but it gives you a baseline for saying, you not only have to say you meet Class B, you have to actually meet Class B. The way that Class B is measured is a screwy way. They put things on a table 80 centimeters above the ground, and they connect it by the power cord. And that's not how you use generators. You put generators on the ground, they're heavy, and you ground them if you're smart, and that makes them a much better transmitter than if you had put them on a table. So when we did the normal things with a generator, it's a darn good transmitter, way worse than Class B spec, and it shows, and we pick up lots of noise. So we now have the transfer function mapped out from one Class B device, but it's enough to give us information for all of them. Good question. Did that answer it for you?
I think so. So, I mean, you get, I suspect pushback from suppliers.
Yeah, because they're probably going to have great trouble meeting this. First of all, they're going to measure it according to FCC standards, which is not good enough. And we want it measured in situ at our facility. Do you still meet Class B standards the way we're going to install it? And if you don't, we're going to have problems. Now, how do we get around that? How do we mitigate it? So it turns out that there are ways to do that. So if it's an industrial device, there are industrial filters. They're all over. The marketplace is littered with them because everybody has the same problem. And you can easily buy a big filter in a big box that you screw to the wall and you connect up, get an electrician to connect it up. And it filters the power going into this big honking thing that you bought. And it will make the power wiring a lot quieter. And it's power wiring in your building that is the antenna. That's what kills you. You're covered with it's like a Faraday cage in reverse. You're living inside the antenna. The second thing is you can filter on the output, and there are consumer devices that can be put on either the input or the output. I found them. They're like $100 each, and there's not a lot of them, but I found them. And so I documented by this device from Triplight, by this device from whoever the other UPS manufacturer. They make some filters. They're not great, but they do work. The industrial filter that we use is the MIF-23. We found it on eBay for as little as $70. If you buy it new, they're more like $130, $140. They're a great filter. And you put that on the input of a UPS and it's quiet. You may also have to put it on the output. The output usually is not where the problem is, it's the input. It's those diodes and the switching that go on and off and on and off, sucking power real fast to charge up that capacitor. That's where the RF gets generated. And then your whole house wiring is the antenna. Same problem if you got solar panel system. Your charge controller is making huge amounts of noise. And it's the same solutions for your charge controller solve this problem. Any other question? Yes.
Basically, if you were to have, looking into putting a solar generation system on your house, you would measure your noise level there, and then tell whoever it was that, you need to make it so that you're not any more than that Class B standard.
Yeah, I would tell them you can increase my noise by 2 dB. And here's the baseline. Good luck. They may refuse to put in the system because they realize, hey, wait a minute, this guy can measure what we've done. And we know our stuff is dirty. But if you offer, hey, I recommend you consider these filters, some of these manufacturers would be willing to try to filter it. There are some manufacturers that sell solar panel gear that they say is really quiet. And you might consider trying those guys. But if you're smart, you make one of these measurements before you have the system installed. And then you do it again and see what happened. And you say, well, hey, you didn't do it. So I want you to add more filters until you get this thing quiet, because I want my radios to work. So I've got a solar panel system that I had installed in my vacation home up in North Carolina. It's a family home. It's been in the generations. And it's noisy as all get out. So I just have to go shut it off. But I'm not there very much. Eventually, I will add filters to it and I'll quiet the thing down. But it's a disaster. And I knew it was going to be a disaster. But I needed the solar panel system.
Why is that house like?
Because I didn't have a chance to put any filters on it. And it's on a small lot. And my antenna is right beside the panels. And the panels are where all the wiring is that the charge controller is sucking power in and out of.
Not a straightforward feed from the power company. You got some sort of a device on it.
I got solar panels. And they go into a charge controller. And the charge controller is a switcher. I mean, all charge controllers are switching power supplies. So they're just RF generators. And their antenna is the wiring to the panels. So that's the first noise generator. And the second noise generator is the inverter. And its noise is on the output side, and it goes to your house and uses your house wiring as the antenna. So I'm caught between two antennas. My solar panels are the first antenna, and my house wiring is the second antenna, and they're both trying to destroy my 20-meter DX. So I just got to turn the thing off. But eventually, I will put in some of these fancy filters, maybe after the warranty runs out. And it'll probably quiet down dramatically after I do that. Because we were able to quiet that generator. We quieted once. It took us a MIF plus 2 or 3 toroids, 100 feet of extension cord, and it disappeared. You couldn't find it anymore. It was gone. We had the antenna set up in my garage. We were using some ham sticks as the antennas. And after we were done, it was there. The S meter was not moving. We could turn the generator on, nothing. But it takes an enormous amount of filtering to do that because the generator is an in-fed transmitter operating with the extension cord as its antenna. And you got to filter, 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 filter. It's got a ground connection for the other half of its antenna system, and it uses the extension cord as a 100-foot long, wonderful multiband in-fed antenna, common mode. So the noise engineering is quite a lot of work to try to solve your HF problems. I think there's one EOC that couldn't even operate on 2 meters. And we had, am I out of time? I don't want to run over. This is a funny story. We had a guy in our group. He's now moved to Texas. He's a really great guy. He taught me a lot of stuff. He was an air conditioning installer, teacher, repairman, you name it. He could do anything with HVAC. He was a very down-to-earth guy. And he became a ham. And we got him through his general class. His wife got through the extra, if I remember. And he put in a 2-meter antenna and a 2-meter radio. And he was really active in our group. And then 1 month he said, guys, something's wrong. There's new noise. We got this noise. We can't hear anything. Our 2-meter radio, we just can't hear anything. Our group worked for 2 months trying to fix his problem. We drove and drove and drove around the neighborhood with a Balfon and with an antenna. And we listened to power lines, and we looked in the neighbors put up something, you know, and we found this pump that the county had, and we thought, what's the pump? And we got the county to switch the pump off. Didn't change anything. And we worked at this, and we drove and we looked and we spied and we did all this stuff. And always it was really strong when we got near to his house. He had put in LED lights in his garage, and the lights were what were making the noise. And once he unplugged the new LED lights in his garage, because he had to make some extra income, so he started up this small business in his garage, that was where all the noise came from. 2-meter noise from LED lights. Would never have expected that. But now we all know none of us are putting in LED lights, not those long ones, you know, because I don't know if there are any that are safe. If you find some that are safe, you let me know.
They're getting better. The first LED light I bought, every time I flipped on that light, the FM stereo radio was working, because it was that powerful. And nowadays you buy one, I find the Walmart brand is actually really low noise.
Oh, good. Okay.
I use Spectrum Analyzer and I read them, and the latest ones are pretty much better.
Very good. Okay. Well, that's great information for us. You want to write an article on that for the North Florida section newsletter? I understand your section doesn't have one.
I had an LED bulb that, it took me a little while to figure it out, but, you know, they do generate a little bit of heat. And it wouldn't, you know, usually you just go around and shut off switches to see if it's that bulb. So, but after a while, I kept getting this noise. Well, the bulb would warm up to a certain point, and then if I shut the switch off, it went away. So, and it was an LED bulb. And it surprised the heck out of me. It even was affected by, it was another room, which sometimes was kind of cool. So if it was hot out, it would do it quicker. If it was cool out, it might not do it at all. But that one bulb, and I didn't check to see the brand or anything, but you know, it was just your typical LED bulb. When it got hot, it would buzz like crazy and on 2 meters.
We've never had a problem with compact fluorescent light bulbs. It's been these long tubular ones that have caused us the troubles. Was yours a long tubular one, or was it a compact fluorescent?
It's just an LED regular light bulb.
Oh, a screw in.
Screw in, yeah.
Yeah. Okay. I haven't had that problem yet, but we could.
Yeah, one of my students had a light bulb burn out on his truck. So instead of buying an incandescent, he says, hey, you know what? I'll buy these long life LEDs. And he told me that whenever he stepped on his brakes, his FM stereo radio quit working. So it was a DC full volt.
Yeah, but they have a switching supply built
But it
into
just
them
got a switching supply
inside the bulb
light.
to run the LEDs.
As small as it was, they did that.
Now, these switching systems are going to be the death of us. You got to understand filters, and you got to have some way to measure it. So you can buy the Tiny SA. The Tiny SA is a cheap spectrum analyzer. And I don't have one, but that would be a wonderful addition. You could kind of calibrate it against somebody else if you can't find any other way to calibrate it. And that would at least get you in the ballpark. It's not going to have the dynamic range that a normal spectrum analyzer has. So you may have a few problems with that, but it beats nothing, and it'll catch loud noise sources. Okay, any other questions? All right, we're going to roll up shop on this one.
I definitely think. All right, let me get your microphone and your clip on one. No.
I laid it on the desk.
Oh, yes, thank you. suspender. Just beard. There it goes. It finally broke loose. All right. Okay. I probably don't need this, but. Okay, well. Okay, where is the wireless one? That little clip-on mic. You got a clip-on mic somewhere.
Set it down.
Oh, there it is. Oh, there they are. That's where they're at. Okay. All righty. I just dropped the mic. Story of my life. Butterfingered and clumsy. I got them all thumbs. My dad used to fuss at me constantly about that. Says, you and your mother, y'all break everything. Yep, that's right, Dad. Dad, I hope you're listening. Yeah, well, he's probably still saying you're still a klutz, son, just like you were all your life. Hard to believe he's been gone 6 years. Mom 1 year ago. Man, wow. Okay, let's go ahead and go into our final program for today. Now you got to listen to me. I'm just going to introduce you to the concept. I was trying to get the hands-on part running, but I still hope it's something to pique your interest a little bit, and we will get that one up here momentarily. Oh, there it is. Okay. The fonts look a little funny probably in because I did this in LibreOffice. Yes, I know. I know I got it. Okay, there we go. I didn't it strip my background and everything else out. So why am I not surprised? Well, it stripped out half my presentation. Wow. It sure did. What's that now? Oh, yeah. Well, because I haven't gone into presentation mode yet. It stripped out over half my stuff. Okay, let's see here. All right. May not have a presentation for you. I didn't have a chance to put this in the PowerPoint, see how it looked or anything else. When you're beset with 14 iPads in lost mode per day, where you don't have time to work on presentations. So, okay, let's see. Open with. That's going to be the same thing, I bet. Yeah, we'll see what the repair option does. Probably finish destroying what I built. And it did a first-class job. All right. Lost all the graphics I put in here too. Nope, I didn't lose the graphics, just the background. All right, well, we can go with what we got. I had a nice, pretty Raspberry Pi Pico in the background, and it decided it didn't want to display that. All right, let's go with that. There we go. Ah, there we are. And let me go over and get the Raspberry Pi Pico so you can actually see it. All right. At least didn't destroy all my graphics in the process. Yeah. I was trying to experiment to load some code, and the LED didn't blink, but it returned the proper code to the terminal just beautifully. So I got to find out what happened on that. All right, introduction to the Raspberry Pi Pico. And I hope that you enjoy. Just remember, Ed Hare, I borrowed this from him. If you like this program, you fall asleep with your head like this, okay? You can go, we're getting about that time of the afternoon. You can even snore, just do it quietly. Now, if you don't like this program, you just sort of go like this. Now, at the end, if all the heads are forward, I'm okay with that. Got that from Ed Hare, who is no longer at the ARRL lab. He finally retired. But I borrowed that from him 20 years ago and have used it ever since. All right, we're just going to do a brief overview today of the Raspberry Pi, where the inspiration for the Pi Pico came from. And we're going to talk about a little bit about the Raspberry Pi Pico and then give you what you need to get started with it. And then some Raspberry Pi Pico resources. This will be on the section website between now and Monday when I have the, after I get home and get a chance to turn all the links on. I got to upload this updated presentation and Mike's as well, because I know he revised it. That presentation as well, but at least this will get you acquainted. And I was hoping to have a demo, but it didn't. And I did it on a MacBook, believe it or not. I actually got the thing to download. I've got the Thorny running, downloaded code to it. For some reason, the LED didn't blink, and I got to find out why. So it could be the board itself. I might have popped it with some static electricity, and that might be why. So I'm probably going to order another Raspberry Pi Pico and see if the results are the same. All right, let's talk about a review of the Raspberry Pi itself. You know, computers used to have large printed circuit board layouts and took 50 to 100 watts of power. That was common when a lot of us got started. How many were in PCs and computers in the 90s in the room? Probably a fair amount of hands. Almost all the hands went up. And I even back around 2000, I explored the possibility of building a repeater controller from a PC motherboard. And it was quite a challenge. But the Raspberry Pi changed all that. How many of you remember the original Pi when it was announced in QST magazine in 2012? Remember reading in what used to be called the Strays column? They had it was a little tiny announcement on a page of QST in 2000, I think March of 2012, April, somewhere around in there. Hard to believe it's been 12 years ago. This little computer for $35. And that was quite an attention getter at the time. Look at the capabilities that the Raspberry Pi 1 had. You could buy it without Ethernet for $25, or you could spend $35 for an Ethernet connector. It had a single core ARM11 processor. It only had one core. That was it, just a single core. 256 to 12 megabytes of RAM, had an Ethernet port and an HDMI port. I watched an interview on YouTube with Eben Upton, the developer of the Raspberry Pi. How many of you have heard of the BBC Micro? You ever heard of that? Maybe some of you have. It was a computer built back in the 80s for kids to teach them how to do coding, how to do programming. And Eben said to him, he was remiss there wasn't anything like that around anymore. And so he said, I wanted to come up with a computer that the young kid at home, middle school or high school student, could play with their computer by using mom and dad's television. And by then, HDMI television had become ubiquitous, even that far back. Had supplanted it. My first computer, and I'm going back down memory lane now. I remember the Commodore 64 or the VIC-20. Oh, now a lot of hands went up. I remember I was an Atari guy. We didn't like commode doors. So yeah, that's what we call the Commodore. We call it the commode door. But I was an Atari 800 XL guy. But they used an ordinary television. You had this, I saw on Facebook a picture recently, this little switch box. And we remember what it was. The old had the slider on it. It had a 300 ohm twin lead output. Now, the folks actually had 75 ohm F connectors that were cable ready, just had the balun on the inside, was all it had. You had to come up and put a balun on the outside, but it had a 300 ohm twin lead connector. You connect up to your television, one went to your computer and one went to the outdoor antenna. So you could switch between the antenna, you put the TV on channel 3 or 2. And now I'm really going down memory lane now. And then your computer could display on your television. Well, Eben Upton remembered this and developed the Raspberry Pi to have an HDMI port. They could use mom and dad's television to start coding. And it had USB ports that only had 2. And it was only 2.0. Now, for the time, that was quite advanced. I mean, we're talking 12 years ago. I actually built an APRS portable station in my very first Go kit, 2014, with that, and got it to work. I ran, what's that APRS, that client that runs on Linux. Now I can't think of the name of it, but I got it to work, and it worked pretty well with a Raspberry Pi 1. But it was the start of things to come. And there is a picture of the ubiquitous. By the way, if you got one of these, I've still got two. You got a collector's item now. And who knows, maybe they're worth some money before too many more years. But the Raspberry Pi 1 was a great start. Well, we had the Raspberry Pi 2 that came out around 14 or 15. The Raspberry Pi 3 came out after that, and the 4. Now, the 4 was one that came out in 2019 that really got into modern times. It had an ARM Cortex A53 processor. It was quad core. I believe the Pi 3 or 2 was dual core, if memory serves me correctly. I've included a link here in the slide. You can go back and look at the specifications of the Raspberry Pi 1 through the 4. It gives you all the specs right on a nice little chart there. It goes to a website, and I've included that link for you. But the original only had 512 megabytes of RAM, and I bought one with 512. I made sure of that. 1 to 8 gigabytes of RAM. Now that's getting more up in our modern computing area. Bluetooth and wireless networking capability were introduced with the Pi 4, I believe it was. And then they switched from the one HDMI port to 2 micro HDMI ports, so you could have 2 monitors. And they were trying to compete. I'll tell you, the Raspberry Pi Foundation and even Upton have really tried to make this computer good. And they introduced also in the Pi 4 USB 3.0 ports. That was another new thing that came out at the time. And there's roughly what it looked like. It went from having 2 to 4. I think that Pi 2 and 3 had 4 2.0 ports. It was 3 or 4 that introduced the 3.0 port. You can see there the micro HDMI ports. They also on the 4 went to a USB-C connector. It needs more power. How many remember in 19 when it came out, they had a fault on the Raspberry Pi 4 that some USB-C, some power supplies wouldn't work. Some of you may remember that. And so you had to have their power supply or one that you knew would work with it. And then they fixed it in future production versions, and that problem went away. It was the way they laid out the C power port in it. But quad core processor, they made a lot of improvements. Now the Pi 5 came out last year. It was another jump. They went up to even a more powerful ARM Cortex processor. The previous version had the BCM 2711 in it. They put in the BCM 2712 by Broadcom, and it had an A76 processor, 2 to 8 gigs of RAM, Bluetooth 5.0 on this version, 802.11 ARC protocol, still the Micro 2 HDMI. Now, some 2 new features they introduced in the Pi 5. PCI Express port. Does that ring a bell what that does? You can have an SSD drive on one now. That is new to the Raspberry Pi 5. Also, a UART port. How many are familiar with UARTs in the room? I know several of the hands go up. UART is the protocol for RS-232 serial ports. And of course, they added an on-off switch on the Pi 5, which was quite nice. You could turn it on and off. And it has a cooling fan port. You don't have to have an add-on and tap into the headers anymore. They actually got a connector on the board where you can plug a fan in now, which is really, really nice. It retained. I'll get to the picture in just a moment. There's the links for the Raspberry Pi 1 through 4, full specifications. You can take a look at them. And Raspberry Pi history. I included those links. I should have put that slide next. This was 11, almost midnight last night when I was finishing this up. You can see now if you're the current Raspberry Pi 5, it has a little bit different look. Notice it's got 2 DSI connectors on instead of 1. And notice the addition of the PCI Express bus on the left side. Now you could do SSD drives with it, which is really, really cool. On-off button was added. It also has, again, it retained the 2 HDMI micro ports. It also retained as well the 2 USB 2.0 and 3.0 ports. It kept that from the previous, but it was an improved Raspberry Pi 4 with a hotter processor. And you can see the heat sink there on the outside case. It gets a little bit warm. This one, I think they recommend you fan it. I mean, it gets quite warm. But that just shows you how far it's come in just 12 years' time from that little article in QST. It was in the strays, like the corner. It was a bottom corner of the page. It was about that much of the page that mentioned the very first one. But now it is It's become just ubiquitous in the ham world, and it's taken off. There's a company making amateur radio repeater controllers out of these. I saw them in Orlando Hamcation. You can make a lot of stuff, weather stations. You mean, your imagination's the limit. Now let's take a look at the Raspberry Pi Pico, what that is. Let's just introduce that concept, what that is about. The Raspberry Pi Foundation also produced and it was mentioned, I believe, by Gordon today, a Raspberry, the Raspberry, oh, come on, it just went out of my head. A miniature Raspberry Pi Zero, that's it. The Pi Zero, it's about this long, about this thick, and I didn't know they were running the SBitX with that thing. Somebody actually tried it and it worked. It has a lot less, I think it's got like 180 milliamps of current drain. The original Pi had like 500, 600, 700 mils of drain, 800 mils, something like that. But the Pi Zero had like 180, and they actually ran SBitX radio on it. So, by the way, that was great on the improvements on the SBitX. I can see it's really matured a lot. I still want to tinker with mine a lot more, but it's the ultimate tinker's radio, and you can play with that one while you leave your 7300 up for nets or whatever, and you can play with the SBitX radio without any trouble. But in January 2021, not to be outdone, they're constant innovators at the Raspberry Pi Foundation. They produced their first microcontroller chip standalone, the RPI 2040, and I included the data sheet for that link in the description. One thing I like about the Raspberry Pi Foundation, Gordon will tell you this, he's been there enough times to read, I'm sure. They have excellent documentation. raspberrypi.org. I think that's the main URL. You can look it up right now. That's okay. When I'm in church, a pastor gives a reference, I look other places. You could do that too. That's perfectly okay if you're on your smart devices chasing a rabbit. I don't mind that. But and this was their first standalone microcontroller chip. And why did they pick that name? RP stands for the Raspberry Pi. 2 is a dual core processor. The 0 is an ARM Cortex M0 processor. Now, in the ARM line, which stands for Advanced RISC Microarchitecture, the ARM the architecture is developed by a company in the UK also named ARMS Holdings Limited. But they don't build the chips. They simply develop the architecture. They license it out to Texas Instruments, ST Microelectronics, Microchip don't build. They have their own 32-bit architecture. But these are 32-bit processors. And they licensed out probably about 10 or 12 different semiconductor manufacturers. And when you buy the chip, you're paying part of the license fee to ARMS Holdings Limited. But they developed the architecture. In the Cortex series, you have A, M, and R. A is the higher end processors like in smartphones. Smartphones use an ARM Cortex A processor. As a matter of fact, the A76, I think, was used in some smartphones, if I'm not mistaken. The M series are the CPU speeds are about 700-800 megahertz a gig. I think on the A76 is 2.7 gigahertz, something like that. But the ARM Cortex M series are slower speed. It's for things that you don't need a graphical user environment. You may have a screen that may just have a simple display on it or something like that, or just with LEDs on it. You don't need a high power processor for that. You buy a processor depending on what your needs are, what kind of project you want to build. And the 4 stands for the amount of RAM, and 0 stands for the amount of program memory. So the one drawback on the RPI 2040 microcontroller, it's got 264 kilobytes of flash RAM, but it has the chip itself. This is where it destroyed my presentation last night. It has no onboard program memory, no onboard flash RAM on the chip itself. It has to be external. That was the way they developed it. Many modern microcontrollers on the market, they got program memory, flash RAM, and then they got scratch pad, that's static RAM that's separate. Static RAM's for your data variables while it's running. Flash RAM is for your program memory. Well, they didn't put any on the RP 2040, but they did give you some nice features on that chip, a USB 1.1 port. You say, wow, USB 1.1. Well, for small devices, that's all you need. If you're just having simple low-speed data or low-speed inputs, you don't need anything else but a 1.1. Remember, this is not for a high-end smartphone. It's not a high-end application. This is for embedded applications. It has 2 UARTs, 2 SPI, and 2 I2C. Now, how many of you know what SPI and I2C is? I know Gordon does, a few others. SPI and I2C are serial standards in the microcontroller world. Chips and so forth either have a SPI interface, that's developed by Motorola. Serial Peripheral Interface is what it stands for. And then I2C was developed by Philips Semiconductor, which today is NXP, I believe, NXP Semiconductor today. That was each, and I've heard for years, SPI versus I2C, which one is better? Well, it depends on what you're doing. And mainly it depends on what peripheral you picked. That is what port you use. SPI has its advantages. I2C has its advantages. And of course, it has 16 pulse width modulated channels. Pulse width modulation would be you could make an LED glow brighter or glow dimmer. That's one application of pulse width. And if you have a smartphone and you can turn the intensity down on the lamp, it's done with pulse width modulation. They take that square wave and do the duty cycle less, which you could do in software and make it dimmer or make it brighter. And of course, the Raspberry Pi Pico has an onboard temperature sensor. That was a little feature they threw into it. And there is the Raspberry Pi Pico specifications. The link will be included in the slides when I get them up on the site, and you can download them. And there is a layout. Notice this multi-port. Now, I'm sorry you can't see it. Oh, it turned out pretty good. It's got general GPIO pins, which you can, they also double SDA and SCL. That's I2C pins. Let's see, let's go over to this side. I'm looking for the UART. You see your UART pins there? That's for a standard serial port. Depending on how you configure the controller in software, determines the function of that pin. There's what called multifunction IO pins. It could be a general purpose IO port. It could, if you configure it, that SCK and SCN, that is a SPI standard. So the purple, and it even color codes it over here for you. If you set it, that is a SPI port, depending on how you configure it in software. If it's blue, it's an I2C port. Again, you can configure the device to do two SPI ports and one I2C. The other way around, you could configure it to do 1 or 2 UART ports, whatever you like. It's entirely up to you as the designer how you configure it. And there is the 4 variants of the Raspberry Pi Zero. And there is mine. That's how big we're talking. You say, that looks familiar. You're right, it does. It's a 40-pin dual inline package, dip header. You could, if you say, I'm not good at surface mount soldering, that's okay. You've got a header on there. You can solder that onto a printed circuit board and make your own project out of it. They put that on there for you. And the cost is inexpensive. You paid more for the pizza today you ate than you would have that. The cost of this is $4. $4. You can throw them away almost. I mean, people waste more money than that in a soda machine in 2 days than they do on a Raspberry Pi Pico. Now you can see the 4 variants up there on the screen. The one on the left is the standard Pi Pico without wireless, 802.11. And the next one is the Raspberry Pi Pico H. It has a serial wire debug connector on it. Notice the connector. That is a debugging standard used in microcontrollers for in-circuit debugging. So in other words, you don't have to pull it out of circuit and put it in something else. You leave it in circuit, and that serial wire debug protocol, I've never used it myself, but it'll help you. Now, but you could use it yourself. And you see the next 2, notice they got that little shield right there you could see on the chip. That's the wireless transceiver. That's an 802.11 transceiver IC. It's got a shield over it. And one is without the debug connector, and one has it. You can see it. It's not soldered onto that one. It's soldered onto that one. And I bought the one, I think, without the serial wire debug, but mine's got the wireless option. And it's just, you can get them whichever way you want. in my opinion, you might as well go and buy it with a, unless you have to worry about current limits or something, buy it with a wireless option. Because then you can build a project and it can connect to your wireless access point or to send data or something. Okay, just to get started with the Raspberry Pi Pico, very easy. You need three things. You need this. Need and by the way, Raspberry Pi Pico development environments will run on Windows, MacBook, Kyle's smiling right now, or Linux. I loaded Thonny on my MacBook and got it to work. And also, there are several development paths. Now, Thonny is what is recommended by the Raspberry Pi Foundation to start with if you're new at Python programming. It was Python for beginners, but you can use Mu Editor. That's another one out there. I'm evaluating that. And that's in Windows and Mac platforms because I downloaded it, got it to work on my MacBook. And it's Kyle's fault over here. He mentored me in Apple, and I mentored him in ham radio. So, but he ruined me and got me into Apple big time. So now I'm an Apple enthusiast now. I just wish they were open source. That's all. But I mean, he said he ruined me for the better, and he's probably right. But I've been my old 2017 MacBook. I love it. I even got VMware Fusion Player. That is the Apple equivalent to VMware Workstation for Windows. I'm running Windows 11 as a virtual machine and Ubuntu Linux on my MacBook. Some of my applications run better in Windows than they do on Mac, so I run them on a virtual machine on my Mac, and I love it. So I just wish the icons sometimes were bigger, especially when you get older, hard to see. But I didn't think I'd like Apple as much as I do, but I do. I just wish they were open source. But anyway, you need a micro USB cable, and you saw one a while ago. Everybody knows what a type A micro USB cable looks like. You need that. And, you need a Raspberry Pi Pico. Three things. That's all you need to get started experimenting. Now, I'm going to see if I can make this video come up here. And it'll show you how to use Thonny. It's about 5-6 minutes long. No, 7 minutes. I'm sorry. And he does an excellent job, this guy here. It's just how you get started on the Raspberry, how you install Thonny and how you run it for the first time. Let's see if it's actually going to work. And yeah, maybe. Cross your fingers. Hope so. There's a student tried on our network. It wouldn't work. Okay, your browser is out of date. That's lovely. I was going to show it to you, but I guess I won't be able to. Oh, lovely. Yeah, figures. That figures. But anyway, and I'm tying my computer up doing this slide presentation. Oh, your browser is up to date. What's this about? Okay, let's try that again. All right, here it comes. Well, let me turn that up so we can actually hear it. Oh.
Is a Raspberry Pi Pico, and
We'll start it over.
Yeah. So you have your Raspberry Pi Pico using Thonny. Or install Thonny if you need.
Well, does that not surprise me?
And afterwards, I'll show you a couple of debugging tricks. All you'll need to follow along is a Raspberry Pi Pico and a USB lead connected to your computer. My Pico has pins on it. If yours doesn't, that doesn't matter. Let's get started. And then you can download Thonny if you don't already have it.
And that figures. Let me turn off the PowerPoint. Now it'll let it happen, baby. Cross our fingers. Okay. Now I turned off the wrong browser window. But we can bring it up. Hopefully it'll be in history. We hope. All right. Nope, it was Edge. I can't stand Edge. Okay. What happened to that? I promise I didn't do anything wrong. Yeah, I guess I didn't pay the bill, did I? Figures. Yeah. Today is the day for it. That figures. It just went off. I promise I didn't do anything wrong. We'll see if we can make it just recognize. There. All right. Now maybe now it'll come back.
Well, partially.
Yep, maybe. I bet it's in the display features. It probably has gone into extended mode again.
Well, that's what I was trying to get.
Yeah, let's go here. Let's go to, well, assuming we even have, we could go to settings. They may have disabled it.
No, they haven't done that.
Now there it is. It's just taken out where you can't find it. Display app. No. Uh-huh. Duplicate these displays. I have this happen. We had this happen during our Skywarn training session in December. I've had it happen in classrooms. That's what made me remember. All right, let's maximize and we'll get right into it.
The good news for those following on a Raspberry Pi at home, you already have Polly. For me, I'm not in Windows today, so I'll need to download Polly. Navigate to phone.org and choose the
See the Mac version in Linux?
my this folder. I can see that Polly is downloaded. I'll run the installer. Normal installer stuff. Right, let's run Polly. Time to plug out Pico, and my Pico has pins on it. It's okay if yours doesn't. That one make a difference for now.
You can buy it with and without headers.
And to your computer through the USB cable. Go to Run and select Interpreter. And make sure that you select MicroPython and Raspberry Pi Pico. It's also a good idea to install or update the firmware first. One last thing that makes life a bit easier is to go to View and Files. And this will show us our file tree on the left. So we have the local files on our computer and the files that are on the Pico. And we are ready to go. I have the REPL down at the bottom here. So this is the interactive Python REPL that's running on the Pico. We can actually execute some live code. I can say print hello world. And the Pico will take that print command and send it right back. The REPL's great.
See, REPL mode is where it communicates with the Raspberry Pi Pico, and the Pi Pico then prints back to your console. So you know it's running.
The script. This complement here is our empty untitled script. First thing is to import some packages.
I think that's where my demo bombed.
This will give us the ability to control the pins on the Pico. I'll assign LED to pin 25. That's the pin on the microcontroller that the LED is connected to. We call that the output. Now, if we create a loop set by phase while through, we can toggle that LED. But if we were to just execute this, the LED would turn on and off so quickly we wouldn't be able to see it. So we need to include a delay. We can say from time import sleep. And we can then use the sleep function to create a delay of, I'm going to say half a second. We can save the script and save it to the Raspberry Pi and call it main.py. If all goes well, you should see on your Raspberry Pi Pico, there is a new file called main.py. The file isn't actually executed yet. For that, we need to restart the Pico. From that REPL interface, you can press Control-D. That's called a soft reboot command. And now that the Pico has booted up, it's going to look for that main.py file and run it.
See the LED on the board blinking?
It's flashing. It's often useful to print text to the screen when you're programming so that you can do some debugging. So let's do that now. I'm going to create a number n and set that to 0 for now. And now, after toggling that LED, I can execute a print command and say that 13 times And now we call upon a variable n is some other variable. Close the quotes and open the y function. So 13 times n, so we put n as our first entry, and then 13 times n as our second entry. 13 times n. Perfect. So the order that you put arguments in here will matter. The first argument will go in this first place, and the second argument will go in this second place. And finally, we just need to increment n. N equals n plus 1. Save that file again. And Control D for a soft reboot. And there we have it. We have a blinking LED, and we also have some nice printed commands on the screen. So this is a neat way to print the values of variables to your console so you can see what's going on. There is a pretty cool feature as well, where if you go to View and Plotter, you actually get to see a plot of various things that are happening in the Pico. So down the bottom here, we have the key to see this. Blue times orange is red. So it's picked up on our print statement, and it's actually extracting information from it. We can see that this line here is slowly increasing in value, and right now it's over 1,000. So this is corresponding to the result of our multiplication. At the moment, it's nearly 1,500. And we have this orange line here. This would be our n, because we have 13 times n. And we can pick that out of the argument as well, because it's actually showing us our print statement. So this is really neat. Looking back at our file tree, we can see that main.py is on the Pico. So if we disconnect the Pico and then reconnect it, we can see that back in Funny, the Pico was disconnected, and also that file tree window has disappeared. Even though our Pico was running our script, to have it appear back in Funny, we just need to use the stop restart function. And now we have our REPL again, and we can see our file tree. However, this doesn't mean that our Pico has stopped executing its code. But we can just start it again using Control D. So we've been saving our scripts directly to the Pico so far, as you can see in the file tree here. If you want to create a backup of that on your computer, you can right-click and select download to my user home directory, and then you can put it wherever you like. Also, the scripts that are on your computer already, you can right-click them and select upload to, and that's the root directory symbol. So that will upload it to your Pico, and you'll get a warning that it's going to overwrite the same file on your Pico. And with that, we are on our way to programming the Raspberry Pi Pico using MicroPython and Funny. I hope you learned something. I know I did. If you have any questions remaining, feel free to open the thread on the Core Electronics forums. We're full-time makers and here to help. Catch you next time.
So what, you said it kind of quickly, what kind
Yeah.
of programming language is it?
It is called Python. It is an interpretive language. Well, I thought I stopped it. I guess it was one of those. Now I'll show you a really neat whole series on there that I happen to like. And I'm going to include these in the slide presentation. This guy right here, Paul McWhorter. Okay, get through the commercials. He does the graphics, puts the screenshots in for you and everything. It's a whole series. He was only up to lesson 7 or 8 last time I looked at it. But yep, he said, and he has series on the Raspberry Pi, the Pi Pico. I mean, he's got all sorts of series on his YouTube channel. It's called Paul McWhorter, Arduino R4 Wi-Fi lessons. That's a new one I didn't know. He's got some interesting, he always has that tropical look in his background. So there you go. Let's go to playlist. I'll let you see that. Raspberry Pi Pico lessons for beginners. He has that series. Fusion 360, Raspberry Pi, the big Pi tutorials. Python, you can learn Python there. Oh, he's put a whole bunch on there since I've looked last. But he always has some very, very interesting. He started out with the Arduino, and now I'll put Paul McWhorter's on the slides too as well, so for your benefit. But what's nice about the Pi Pico It is so well documented at the Raspberry Pi Foundation website, raspberrypi.org. And so is the regular Pi, the Pi Pico. It's all very, very well. And you can see how easy it is. You program it with a USB cable. First, you load your you load the bootloader to it when you set it up, and you saw in the video where he walked you through that. Then you simply dump the code to it and run it. It interprets it, and you stop it, edit it, and redump it to it and run it. It's a great tool. If you're new to programming, Python is sort of like the basic of today, basically. It's similar to basic language now, but it's it's a little more forgiving on variables, how it handles it. You could when we had the code up here, let me see if I still got that or not. No, I don't think I do. But you saw there with the import commands, he was importing Python libraries. He was calling on those libraries, but you have to import them to call on them. That's a wonderful thing about Python and C++. They are object-oriented languages. In other words, you can one object can call on another, and that one can call on another object. If you change the programming in this object, these two don't have to change because it's like redesigned a tool. The interfaces are the same. You can add an interface too, for that matter, but your existing code don't have to change when you update an object. That's a wonderful thing about object-oriented programming. Let's reopen our slide presentation now. Okay, let's see him at the bottom here. There we go. Yes, I know about that. Yes, you destroyed my presentation. Oh, Microsoft. I'd have my MacBook, it wouldn't destroy it. Did I just say that? Okay, let's start from let's start from here. If I can. From current slide. Okay, there we go. Okay, let's go back to that. Resources for the Raspberry Pi Pico. I put links in the program description for you about it's the Raspberry Pi Pico homepage, has full specifications, and again, they are very well documented. They did a really, you've seen some products out there that the documentation is so, like some of the Chinese radios we have, they're scant, or they're not. The Raspberry Pi Foundation, they've done a good job documenting things. This will be in the slides. You'll be able to pull them down. They will be hyperlinked. You'll just be able to click on them, and it'll take you right to the web page. Program, by the way, you could program the Raspberry Pi Pico from Visual Studio Code now. You can do it from that. And that also runs in Windows and Mac. Does it run on Linux as well? That's the part I don't know. I think it's just Windows and Mac it runs on. A Visual Studio Code. Well, it wouldn't matter. I just run it in a virtual machine. And so there you go. But yeah, I see I made a mistake there on the link. I got to fix. And I'm going to recommend something to you if you develop. You see the picture up there? Get you one of these little breakout boards. I have in my truck, I built an actual full microcontroller development station. But you can see, and I'm going to show you right here, this Raspberry Pi Pico will seat right into this. Right there. I didn't put it in all the way, but it allows you to play with it. You can power it externally from here. By the way, a caution on the Raspberry Pi Pico ports. Like most modern microcontrollers, don't put over 3.3 volts into it. Some controllers only handle 1.8. That's modern microcontroller design. So if you use the ports, you have to buffer them. And if it's a device that has like 5 volts, TTL voltage levels, you'll have to have a buffer chip. It will not like it if you go over 3.3 volts. You can damage the microcontroller. So you can see it breaks out the headers for you to use little jumper wires and go to a breadboard and interface other chips to it, or display, or whatever you want to interface to it. You can then experiment without ever soldering. That's the advantage of it. You could get you a little breadboard, get the little jumper wires to go over into it. Now, good thing you're not designing anything high frequency, like Gordon talked about today in the S-bit-X. They didn't drop in enough caps in places, and it actually produced spurious oscillations that were not supposed to be there. The original S-bit-X had a problem. It destroyed the finals through VHF parasitics. And they've gotten through that and have resolved that since then. But it's good. And this board, by the way, you're going to like this. You can buy it on Amazon for $10. It's dirt cheap. Amazon, and you can search that there, Keys. No, I didn't spell it right. It should, no, I did. Keys Studio Raspberry Pi Pico IO Shield. It's the Raspberry Pi equivalent of an Arduino shield, but it's a breakout shield. And notice on the board there, you'll see it on the screen. I'm going to pull this off so you can see it. They do have a voltage regulator on here for power. If you put it in that DC power jack, that's a 3.3 volt regulator. You can see it right there in the middle. And there's some filter caps on it as well to keep down parasitic oscillations. And then when you design circuits, you know you have to run analog ground and digital ground. You got to be very careful. On these modern chips, you can get some VHF, UHF parasitic oscillations if you don't. But when you're breadboarding, you're probably not going to be worried about that too much for the purposes of this. But if you start getting up in the megahertz range, you got to be concerned about that. Length of your wires can add extra inductance and capacitance, and it can become an oscillator when you didn't intend it to. Now, I guess the important part, questions, comments. I'm not the expert, but I'll get you started in the direction. Yes, Gordon. Yeah, the Pi 2W. You mean assuming you can find one? Huh? Now, Adafruit and SparkFun, I think, are the distributors in this country. Well, the Pi W is the Raspberry Pi Pico is much lower in capability. It's a Cortex M processor. If you want something that don't quite have the horsepower of a full Raspberry Pi or a Raspberry Pi Zero W2, a Raspberry Pi Zero 2, I think it is. I think you must have the second version out now. You may have something that don't need a lot of horsepower and something therefore draws a lot less current. The Raspberry Pi Pico don't draw nowhere. I don't even think it draws 100 milliamps of current. Probably draws a lot less than that. Look at the header and look at the size of that voltage regulator. It probably don't draw more than 20, 30 milliamps, maybe 50 tops. I should have looked at the specs on that to see what the Pi Pico itself in there, but it'll be in the specification sheet. But the current draw is much lower. So if you need something for an embedded application that needs wireless connectivity, the reason they made the version without it is without the wireless transceiver, it draws less current. So if you need something like gather a weather station, you should be able to build a weather station that parse data to the outside world with that. It's only pulling data from a few sensors every few seconds. There's plenty of horsepower in that. You could make it run a basic OLED screen. You could use that Pi Pico, I would imagine, to control QRP transceivers. If all you're doing is moving the frequency and need a display, and it would have more than plenty enough horsepower for that to run a simple QRP radio or something you want to homebrew. That's where it has an advantage. Now, there is the STM32 blue pill that's based on an STM32F103 controller, and it's about around the same price, but it has a lot more horsepower. But where it's limited, and what's nice about the Pi Pico is the amount of support out there for it. There is more support than there is for the blue pill. And I'm not putting the blue pill down. It's a good device. And again, I think they're about $4 or $5 also. And you can buy this. I bought mine with headers. You can buy it without headers. You can buy it just with through holes in the board. You can buy it that way as well. So any other questions? Yes, sir. Zero. Probably, I would say that's about right. I'd say it's about right. I think and the W would mean wireless. You could buy just the 2 and then the 2W. So yes, it does. It has a micro HDMI connector, I believe. Maybe it's a mini. I can't remember which. Yeah, Adafruit and let's go back and compare them. It's a little old, but that's okay. Let's go here. Hopefully this will work. Maybe. Yes, I want to open this file. And now I got to come out of presentation mode. All right, let's do this and stop presentation mode. And that, and that, and there we are. You can see there that compares the I don't think the Pi 0W is in this comparison, but that's the product data overview chart. It's a little bit dated, but it tells you the first 3 Raspberry Pis and what their capabilities were. So you can see the evolution of how they improved. But the Pi 0W would have it like in running the SBITX. Yes, it's got enough horsepower to do it. And so, hey, if you want a lower power SBITX, that'd be the way to go. Or if you want to incorporate it in another case, which you can. That's what I like about the UBITX. Now, how many of you heard of the UBITX, the predecessor? It's an analog transceiver. The SBITX is an SDR radio. The UBITX, and I actually have one right down here. I'm going to look at another one of those where my job gets in the way of my hobby. Yeah, Kyle and I are frowning both because ours get in the way often. That poor guy starts before I do in the morning and goes till after I do usually. But some days I feel like it all comes at me like it comes at him. But you could use this right here to do special things with it. I mean, you could use it for a sound card interface, control a sound card chip or something. I mean, the applications are limitless. It don't need a lot of horsepower, therefore it don't draw a lot of current. So it's a niche processor. It'd be like a PIC microcontroller, a high-end PIC, maybe a 16-bit. And yeah, I still like PICs, don't get me wrong. The RSGB has an excellent book, and I have a copy of it over here. It's their microcontroller book. They talk about the STM32. They talk about the PIC microcontroller and the Raspberry Pi Pico, I believe. Yes, sir.
Different Raspberry Pis are wireless, and what flavor of wireless?
The Raspberry Pi, I believe 4 and up had wireless options. The Pi 0W, W meant wireless, and the Raspberry Pi Pico W also means wireless. Look for the W. That tells you it has the wireless. And what matter of fact, I think if I'm not mistaken, it may have went back to the 3. Oh, yeah, it was the 3B. That was the first one that had the wireless transceiver. I kept thinking it was the Pi 4, but the Pi 3, yep, it had that little shield on it. You look for that wire because it's a shield for your transceiver. Remember, you're talking about something that generates 2,400 megahertz. Better have a shield over it. Oh yeah, 802.11 is the standard. There's A, there's B, C standard, N. B is legacy. A, C, and N are still more modern. And A, I think A is N, and let's see. I think C is a different band, if I remember correctly. I can't remember the standard specifications at the moment. It was 802.11. You have an A specification. B is legacy now, as they call it in the industry. That's the industry standard for obsolete. Yep. Yeah, that's the. I think that's the C standard is 5.8 gigs. And because you have 2.4, that depending on which standard you run. I mean, the standards are all published. You can go read and find out about it yourself. But they tried to make the Raspberry Pi where it was 2.4 gigahertz, 802.11 capable. So you could connect it because the truth is, you've heard of the concept, the Internet of Things. John, let's see, Pellant, W1JP, has done workshops here for us in TECHCON. I want to get him to come back on doing Internet of Things, taking a device. He actually had it set up to read room temperature and send it to a website, all from his device. He showed you, he actually did a hands-on live demonstration. And he likes to use JSON objects and so forth. And somebody had a hand up? Oh, okay, I'm looking at the screen there. I thought somebody had a hand up. Okay, well, at this point, let's see. I guess I'll do this for what it's worth. And let's see here. I'll just put this up on the screen because if there are no more questions, now go and experiment. No matter what it is you experiment, go and experiment with something. We as ham radio operators, we're that 3% in this room that likes to get our hands on hardware and experiment. Developments and things like NXDN depends on those of us that experiment in back rooms. And I encourage you find something you're comfortable with and experiment with it. Dig into it and tinker. Hey, if you do wrong, you learn what you did wrong. I mean, what did Gordon talk about in his program? How many times he blew up Raspberry Pis till he got something right? Well, he learned and was able to share that with you. So go and experiment. And at the end of the slide presentation is my contact info. I'm going to put this slide presentation on my personal website as well. So if nobody else has any questions, let's give out some door prizes. We didn't do that today. I was so focused on the presentations that I lost track of what we were doing here. So if there are I don't see any questions online. So we are going to terminate the stream online at this time. I get to my mouse here. There it is. We'll hand out what little door prizes. I do that. Okay, and here we go. Oh, yeah, sure. As a matter of fact, we're going to terminate the live stream here and have a little discussion about some ideas for future TECHCONs as well. Anyway, thank you very much for those attending.